Hey guys, in this lesson we're taking a look at another trig ratio. This one's called cosine. Cosine, given a reference angle, is going to be the ratio of the adjacent side over the hypotenuse. So if we look at our triangle, hypotenuse is the easiest one to find first. It's going to be directly across from that right angle, so there's the hypotenuse. And then let's say the reference angle we're using is A. Adjacent is the one that's right beside that reference angle. So if we're looking to do an example of the cosine of an angle is going to be equal to adjacent over hypotenuse. That's the basic definition. So if we use it for this picture right here, the cosine for our angle is going to be equal to the adjacent is AC over the hypotenuse is going to be AB. And you can use this cosine ratio to just write the rule. So things it can be used for, it can be used to write the rule. And then it can also be used to solve for a side. And you have to be given one angle and one side to solve for that one side. They could also ask you to write the secant ratio, and it's given a reference angle. The secant of an angle is the ratio of the hypotenuse over the adjacent. So the secant is the reciprocal for the cosine. So the secant of an angle is going to be equal to hypotenuse over adjacent. So if we use that for the picture we have down here, hypotenuse is the easiest one to find. So there's the hypotenuse and there's the adjacent. So the secant for this angle A, our reference angle, is going to be equal to the hypotenuse, which is AB, over the adjacent, which is AC. And pretty much the only thing for right now that they're going to have you use this for, you're pretty much just going to use this to write the rule. And in order to be able to do that, you have to be given the two sides. Same thing here. Okay. Looking at the inverse cosine, this is the way you solve for angles. So if it says solve for an angle, no matter what kind of a right triangle you're working with, you're using the inverse function for your trig function. Now if they give you an adjacent side and a hypotenuse to work with, then you're working with the inverse cosine. So the inverse cosine of an adjacent side over the hypotenuse will give you whatever angle you're trying to solve for, as long as it's one that can be a reference angle. So if we're doing that for this example right here, this is going to be our hypotenuse. This one is going to be the adjacent. So the inverse cosine for this triangle is going to be the adjacent, or AC, over the hypotenuse, which is AB, and that will give us angle A. And so this is what you would put into your calculator. And that'll give you your angle. And remember, whenever you're doing those inverse functions, they're going to be the one that's right up above your regular functions. Okay, so if we start trying some of these out. First one we have tells us to calculate the cosine of the indicated angle in each triangle. So if we look right here and see the arc mark, that tells us that it's the indicated angle, and they want us to write our answer in simplest form. That means no decimals, it's got to be a fraction, and then within that fraction, no decimals in the fraction, and then no square roots in the bottom of the fraction. Okay, so if we start trying this out, they give us 3 square root of 3, and they give us 6, and they want us to calculate the cosine. So right off the top of your head, you should remember the definition for cosine. If you don't, look at the notes. Cosine of an angle is going to be equal to adjacent over hypotenuse. So I wasn't even worried about what was going on there, just straight writing the definition that we had right there. So in this case, we're working with cosine of B is going to be equal to the adjacent. So if we're looking at angle B, that's going to be our opposites directly across. This is going to be our hypotenuse because it's right across from that 90-degree angle, which makes this one be the adjacent. So our cosine of B is going to be equal to 3 square root of 3 over 6. So if we look, we don't have any decimals. It's got to be a fraction. It is a fraction. There's no decimals in the fraction, and there's no square root in the denominator. But it does say simplest. So there's nothing to simplify with the square root. That's as simple as it can be. So I'm going to ignore it. And if you look, there's 3/6. The number 3 and the number 6 are both outside of the square root, so they can be simplified together. 3/6 will simplify to 1/2. So the cosine of B is going to be equal to, I'll write the 1/2 and then put the square root of 3. This needs simplified a little bit more. And this kind of works like whenever you have 1x, if you simplify it all the way, it's going to give you x. It's the same thing here. Technically, if you simplify it all the way, you're going to have cosine of B is going to be equal to the square root of 3 over 2. And there's the answer. They could also have you use a calculator to calculate values. So we would take those and just stick it in the calculator exactly as we see it. So we're looking at cosine of 43 degrees. Hit the equals button, and notice it says round to the nearest hundredth. You got to be careful and read what it's asking to round to. Hundredth means 2 decimal spots. So if we look, we've got 0.73135. So we want 2. So we check out the 1. The 1 is less than 5, so this is going to stay 0.73. So that's going to be our answer for the cosine of 43 degrees. Looking at the next one, it wants us to calculate the secant of the indicated angle for each triangle and then write the answers in simplest form. So secant. So before, notice I haven't even worried about what's going on there. Secant. I'm remembering the rule that we wrote in our notes at the beginning. The secant of an angle is going to be equal to hypotenuse over adjacent. So the secant of an angle is going to be equal to hypotenuse over adjacent. So there's the right triangle they've given us to work with. There's the right angle right there, which means this will be the hypotenuse. That means we need a reference angle. The reference angle will be this one right there. So that means this one right here is going to be the opposite. Means this one right here is going to be the adjacent. So if we set up our rule, the secant of angle P is going to be equal to our hypotenuse. They didn't give us the value for the hypotenuse, but we do have the other 2 sides of our right triangle. And remember, we can use Pythagorean's theorem to solve for that 3rd side. So this is looking to figure out which one's going to be C. Remember, the one directly across from is going to be the C. So that makes this one be A. So 6 squared plus 3 squared, because we're doing the A squared plus B squared is equal to C squared, is going to be equal to So 6 squared is 36 plus 3 squared will be 9. It's going to give us our c squared. So 36 plus 9 is going to be 45. And that's going to give us our c squared. So if we take the square root of both sides, c is going to be equal to the square root of 45. But the square root of 45 is not simplified down all the way, and to check and see whether or not it is, we can just write a factor tree. So with a factor tree, you're writing things that multiply to make 45. So in this case, it's going to be 9 and 5. 5 is prime, so that's as far as that will go. And then 9 is made up of 3 and 3. So if I put this inside of a square root, the square root of 3 times 5, and I'm going to group them into twos, if there are twos. I'm going to group them into pairs because squares undo square roots. So if I take the square root of 3 squared times the square root of 5, the square root of 3 squared is just going to be 3 square root of 5. So that's going to be our third side here, 3 square root of 5. So secant of p is going to be equal to the hypotenuse, 3 square root of 5 over the adjacent, and the adjacent is 6. And again, this is another case where, okay, we've simplified that right there, and the square root of 5 is as simple as it can be. So we cover up and we check out the numbers that we still have left. So we still have 3 6 left, and just like above, we could simplify it to 1/2. The secant of p is going to be equal to 1 square root of 5 over 2. And if we simplify it all the way, the secant of p is going to be equal to the square root of 5 over 2. You could also get problems that ask you to use a calculator to approximate each secant ratio. And if you look on your calculator, just like our other sister functions to our 3 main trig functions, there is no secant button. So what you have to do in order to be able to type in the secant, and make sure you try this with your calculator to make sure you're calculating it right, the secant is going to be equal to, you do 1 divided by the cosine of 89 degrees. So what you'll type in your calculator is 1 divided by cosine of 89, and then hit your equals button. So 1 divided by the cosine of 89, and that should give you 57.298. Now I'm only writing those 3 because it tells us to round to the nearest hundredth, which means 2 decimal spots, which means this one is going to tell us whether or not the 9 gets rounded up. So 8 is bigger than 5, so 9 is going to get rounded up to a 0, but it's really being rounded up to a 10, which means this 2 needs to become a 3. So if we write our answer for secant of 89 degrees, it's going to be equal to 57.30.